Welcome to Pantechelearning. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. Now we are going to see regarding towards Otsu thresholding, which is one of the most widely used kind of thresholding for all the image processing and computer vision applications. Among that, if we start with Otsu thresholding, means it is named after Nobuyuki Otsu, which performs automatic image thresholding. So in simplest way, if you are just applying this kind of threshold, means it is able to segregate the foreground as well as background. So for example, whenever we are just providing that respective area, so here this is considered as the foreground and the square is considered as background over there. Now when that particular Otsu threshold that has been applied, so it will be in this case which is able to follow as easy as possible. Similarly, whatever the application which we have done previous, or like the app segmentation, or it may be the k-means, we have to provide the clustering value over there. So that brings the main difference while compared to the Otsu as well as the other thresholding. And on to that, if you are just going for this kind of variance, so here we have to measure the most of the time in the form of variance only. So how that particular variance is applied means total variance. So from that particular total variance, we have to get the between variance as well as applied variance over there. On that basis only, here we will be able to collect the entire data. So like if an image is getting segmented, onto that segmentation, we are able to do segmentation in this particular way, means for that what and all the process will be there means, so in between variance. So in between variance means for the respective image whatever we have provided. So this circle as well as this particular rectangle will be taken as in between. Sorry, not this rectangle. This one we have applied. This is taken as in between variance plus a total variance. Sorry, the applied variance. So there may be some size differences. I hope this will be easy to learn. By combining these two images, it is able to collect the data which is foreground and which is background. So whatever present inside the foreground, automatically it is changed into the white color. Whatever it is present in the background, it will be considered as black. Similarly, if you just go for the segmented, means whatever we have applied the threshold parts. So from the threshold, we have to select the foreground and background. That is much more difficult for all the process. So while compared to this kind of application, Otsu has an advantage in working this kind of inputs. So now let us open our MATLAB. We have to access our directory, copy the address. Now we can take a new script and start our coding. So here we are going to apply that Otsu directly for the image through histogramical process. So from that histogram variance only we are able to collect that foreground and background over here. So how it is done means, first we can provide a variable to store the image whatever we are reading as imread. Now within that particular part we have to provide the respective image name. So for that I am taking 12.png as input. Now within this I have to provide two variables in order to collect the complete data, because histogram, it is a 2D data which mostly applied for the purpose of graphical representation. So from that I am taking these two variables and I am applying the histogram, and the value of histogram whatever I am going to apply, it is nothing but 16. So to collect the data we can provide anything whatever we need. To plot it in the form of stem, so stem graph only here I am choosing. Stem graph, bar graph, anything can be applied. So both the data will be read over here. Now after this, from that respective histogram only we are going to collect the threshold value. So for that the keyword is Otsu thresh. From this I am taking the counts variable, because those variables only will be containing the threshold. Now after correcting the threshold, we have to convert into the binarize, like the binary data. So for that im binarize, now it should be displayed. So we are going to display two parts, so that respective images we have applied as input, and we can save it. Since this is already gray, we no need to change anything for the grayscale, and this Otsu threshold we are not able to see. But what are the threshold which we have applied for the binarization, it is able to see over here. Now the same thing what happens if we apply for the color image. So color image, it is not possible to binarize. Now for that particular same image, I'll just convert into grayscale. So here we can see that respective foreground as well as the background once when it has been binarized automatically, and here also we can see that variance inside that histogram part. So this variance only, it is matching that respective colors for the input, and therefore now the next thing is we can try with another one image also. So how that particular binarization has been applied onto this thresholding part. This way only we will be able to apply that functions. Now similarly we have many kinds of implementation, especially if you are going for this kind of also thresholding. So through that programmatic explanations, or let it be multi-level image segmentation thresholds, all the functions here we will be able to apply. That is also itself. Everything works basically on the concept of Otsu thresholding alone. So inside that Otsu's type itself, we can try now multi-level thresholding. So that multi-level thresholding, it will provide layers or different applications over here. So for that also we have to start with reading an image. So im read, then bracket image, taking the same image over there. So along with that figure, I'm displaying row of white. Previously we have given it as RGB to gray, so that if RGB only it is there, means it will be able to convert into gray. And this variable stands for everything, like even if it is RGB or if it is also not an RGB, like IM to gray, we can use this command, which is easy. Now after this we can just move on to the required parts. So like first we have to provide the multi-level, multi-thresh from the grayscale. Then after that we have to just apply this particular change with quantization. Based on that particular quantization only, we will be able to return the threshold level into multi-thresh, because from image which is segmented from two different regions, we have to bring back that level. So for that only we are using this quantization. So for that I am quantize. So we have to take the original image as well as the level of multi-thresh. Now we can display. So here am show multi. So all the outputs are looking similar only. Minute changes in their applications will be changed. Now for the same thing, if you want to just display, but difficult only to see the multi-level value. Anyway, let us try whether it is possible to see that. Multi-thresh alone cannot be seen. Now the same thing if you are taking for a color image, means the drastic change will be there. So this will be the exact segmentation or levels. So each and every level value only getting increased, but on the way of output if we see, means it is almost same only. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.